Alright, should be another draft physics video production. Feels like one, sort of. Anyway, at the end of this video, I think I'll do some discussion of the simulation software and the different mathematical kind of problems in terms of converting the concept into something mathematically simple so it can be rendered by a computer quickly. That kind of stuff. Efficient ways of generalizing the functions. Something like that. Anyway, so it might not be for everyone. Anyway, just for superior mind and simulation guy, as I shall call him. Anyway, Tea Party LA. Curious, if you were to take an extremely powerful magnet, wrap a coil around it, and induce an electric current, what would happen? Well, there's probably a video somewhere that does that. I would imagine it would go one way or the other, depending on which way the current's going in the coil. It's basically still a solenoid, and the problem is there's really no way to have magnetic balance. That is, you can't put a magnet in there and somehow have the two forces be perfectly equal in terms of the coil creating a positive end, an end that's going positive, and an end that's going negative. So I would imagine that it will make a decision if it's anywhere close to the middle and just end up going one way or going the other way, shooting out of the coil. And I would imagine it would shoot a little better than a piece of steel, but I can't, hard to say for sure. Because magnets, especially neodymium ones, they sacrifice a lot of, you would say, the density potential of the substance, weight, because it's ceramic, and they have to have some way to make it rigid. But I'm just not, can't say for sure. But anyway, all right, it's okay to ask questions, I suppose. But I haven't done enough research to say exactly for sure. It's either going to chatter, it's going to move back and forth very fast and aggressively, or it's going to shoot out one end or the other. It's pretty much the answer, I think. What is all this crap? Superior mind. Okay, so he's done a simulation. So he's asking a simulation question. So we'll show what he's done. So it's interesting. Basically the same idea as make electrons and protons and create a force around them and see if you can get the forces to interact the way they should. And he generally gets the same thing the other simulation is producing, which is they tend to pair. And but yeah, it's the subtleties are important in terms of somehow you've got to create the mechanism does create clearly in nature a balance between the low pressure and the high pressure, the pushing force and the attraction force, which doesn't really exist. It's the absence of force, so and then you got to create the right density of force to movement of the material, so it's a little complicated. But anyway, yes, clearly it shows the idea works in the sense that they don't just all fly through each other and do stuff. They do tend to keep their independence, and they tend to pair. But yes, I'll go into later some of the subtleties that are tricky. Pretty much. Okay. I was wondering about how we could predict the direction of the 90-degree reflections occur. Yeah, and so that's something I've been working on, and so I'll do a brief on it now, maybe. Maybe just there has to be some kind of mechanical recognition, some sort of mechanical thing. I mean, you can create cheats and just say this will be the rule, or that are that actually require almost ESP between the particles, and you want to try to avoid that kind of stuff. So I'm tending towards a rule that's pretty simple in the sense that the deflections are always in the opposite direction of whatever perpendicular direction the thing is moving. So if the electron's moving this way, and the idea is it's going to get hit by one of these particles that deflects, then if it hits in the direction of its motion, the perpendicular, well, it doesn't matter. If it hits sideways, then it goes the opposite direction to the motion. So if it's moving this way and the red thing and a blue thing hits it, the blue thing just goes the opposite direction of the motion. And that would be the simple rule. That's where I am now. Anyway, I also started a sim, very rough so far, based on the one being worked on. At the moment, I have the blue force deflecting off the red at 90 degrees, but choosing which direction randomly. Yeah, the trick with random, well, there's lots of tricks to it, but yeah, I'm just not, it obviously creates a problem between the attractive forces can be destroyed by random. So random doesn't really work. Just to get a rough version of what's happening, I thought something with the rule might produce more accurate results. Yeah, you gotta just play with it. So far, the rough scale inaccurate version does demonstrate proof of concept similar to the simulation you've shown. I do have some calculation inaccuracy due to sloppy optimization, which I'll fix and find some free time when I find some free time. I appreciate any effort is good. Thanks. So interesting. So this is sort of where we are with the other simulation. Why is it doing this bullshit? I didn't click on moving thing. Well, I guess I did because I clicked on the corner. So this is, why isn't it playing? Anyway, there it is. But there's some improvements that haven't been put in yet. But anyway, the idea is they tend to pair pretty simply, easily, so that's working fine. But what they're not doing is flipping and clumping, which they should be doing. But it all has to do with how you have to change you have to sort of change what they do exactly when they are right next to each other. The dynamic does change a little. The boat rules change when two boats are connected. But you get the idea that they do pair fairly easily. It's not nearly as strong as it should be, but again, that just has to do with how fast you make the force go based on how fast these things go. So that was one of the big issues. So that's what I'll talk about mostly, is just how to, because maybe somebody else can make a contribution to how you create the idea of the drag problem, recognizing that you can't make a field dense enough. The whole idea of the momentum, the idea, because you really can't afford to have the computer do 24 seats in the boat or 100 seats in the boat and figure out, the exchanges between the guy who jumps in and what guy jumps out and all of that kind of stuff. And so you do have to find a simple way to mathematically appreciate the fact that there's rules. Something like that. So anyway, but yes, moving right along. I mean, they do clump into bigger clumps. It's just that they're not exactly the way they should be as magnets. So anyway, it's progress. Alright, moving on. Quinteca. So Gary, do you think you'll ever hook up with Yvette Satie? So, this has absolutely nothing to do with this channel. It has, this is the Amendum channel, and it's a stupid question anyway. So, I mean, it's this whole idea, these people think they're liberal, or they give a shit in some way, or they're not just some knee-jerk religious kook. The fact that somebody would change their sex is sort of their business. it really doesn't mean anything, especially if they want it not to mean something. Now, some of them want it to mean something because they're flamboyant and they want attention and all that kind of crap. Well, that's their business. But some people maybe don't want all that attention, and they don't want all these stupid jokes and all this kind of bullshit. You know, and if you really gave a shit about the subject, or you were really some sort of liberal who could understand that people have all kinds of personal issues because we're all traumatized by our existence on this planet, that maybe you just lighten up and say, isn't it their business? I mean, isn't that sort of my business even? Like, let's say I didn't care, you know. I wasn't, I didn't get off sexually in traditional ways or something. Wouldn't that be my business? How's it your business, asshole? It's just kind of rude. Like I said, it's just rude. It has nothing to do with the channel. It's just bullshit. It's just more asshole behavior. I mean, these are the same assholes who complain about some kind of degrade in social structure or in our civilization, or find some fault with how things are run, and then they're part of the problem. They're not part of the solution. You're not going to solve any problems with this kind of bullshit, asshole. This trivial, stupid crap. This 12-year-old kid kind of ignorance. Just fuck you. Fuck you. You're fuckable fuckable in a nasty way for lots of past behavior. But I just can't believe you still haven't grown up enough to know that this was just really a stupid thing to do on this channel. Just really, really, really stupid. Okay, so this asshole is also completely blockable. But I mean, what do you think my response was going to be? You think I think it's funny? No chance. I mean, you're forcing me, okay, to engage in some conversation about why I would or wouldn't have sex with a transvestite, and that's relevant to this channel? I mean, God, you're stupid. Fucking stupid. Anyway, I mean, yeah, people, you can't fucking figure out just how stupid, how dumb will they go. I mean, it just gets lower. The bar gets lower and lower. Oh, so we should probably read some of this snark. Do you realize this guy's insane, right? Right. So you're insane because you would disagree with the establishment, and clearly physics has become an establishment. They're making really extraordinary claims about reality. They have this, bizarrely, they don't even have any coherent principles. I mean, one physicist will tell you there's many worlds, and one will tell you, no, there's just subtle fluctuations in the flow of the whatever, and then others will say that no, our consciousness is creating the reality, and nothing ever happens until some human walks up to it and says, "Are you doing something?" I mean, they have bizarrely inconsistent theories of what their own physics means, and then the stuff they all agree on, some kind of bent space geodesic thing, doesn't explain anything about what motivates the actual matter to move in any way whatsoever. It just basically says it moves, magically, because there's no way to conceptualize whatever this bent geodesic thing is that's supposed to be compelling things. So if you find that just totally inadequate as a concept or a theory, it is no better than somebody saying, I have a theory of evolution, and it involves the imagination of the organism, and his imagination, he thinks he's a swan, and his genetics change because he thought about being a swan, and now his genes have changed, and so his kids come out swanier. I mean, what the fuck? If I said that, you'd say, nah, you got good reason to think there's something wrong with that bullshit. I mean, it's just, you want to say I'm wrong? Fine. You want to argue that, I've made a misperception somewhere, that fundamentally somehow you want to point out how I've made some huge logical mistake? Then point out the huge logical mistake. Not trusting physicists. Is that a huge logical mistake to say that, well, maybe these guys have their fucking, whatever you call it, a slide rule way too far up their asses? You won't even concede this. And I've shown the evidence. I've shown how bad it is, right? I mean, they have no explanation for what breaks the photon going into the single slit. The double slit, they don't explain the fact that there's two patterns. The triple slit, they don't explain at all why there's images being projected at the locations and how wave interference could possibly project images. And then you can just go to every experiment and point out how they have perversely exaggerated the evidence, the strength of the evidence. The Eddington experiment is just plain crap, never repeated. They got satellites in space. They've never used one to do the Eddington experiment, which they could do every single day. They don't have to wait for an eclipse. They have perfect conditions every single day, and they haven't done it once. And you want to sit there and ridicule me. All right, back. Yes, wardrobe change. It's got cold, wet, and windy out. Anyway, winter is arriving and such. Anyway, I think I've said enough about that. Yes, I understand that you're insane. How much is Gary paying you to do those dumb simulations? So, again, just useless snarkyisms. So nobody should really investigate anything. Nobody should do anything at all. You should just sit there and line up in the Borg and eat whatever crap they put in front of you, even if it just plainly, obviously looks like shit. Like it's just undercooked, underdone. You'll just fall for it, and you just chew on your gristle. Anyway, both of these people are dishonest sophists, plain and simple. And dishonest how? So again, there's just nothing. You people can't provide any evidence for your accusations. I mean, you can't back one up with quotes or something. It's just so, and you're the one defending the people who are basically dishonest in the sense that they talk about their great evidence, that we've proven it over and over again. And if you really look at the evidence, it sucks. Like with lensing and this whole argument that they've somehow verified this gravity bending light with all these other experiments. So if you look at the experiments, they're insanely complicated, some of them. Just, you just say, okay, I trust them. I trust that they know the difference between scatter and not scatter. And I mean, they just have obvious places where you can say maybe that's the wrong conclusion. Like with the radar experiment and the two-slit thing, where it's obviously a problem that, the geometry for something as simple as jamming the radio is exactly the same. The consequence you'd have the same result. If you thought about the experiment as I'm going to jam the signal, you do exactly the same thing that you're doing the slit experiment. And yet you're certain that no, it's the photons interfering with each other because they're waves. It can't possibly be that my radio can't pick up two signals at the same time. I mean, come on. Why do you people have to be this obnoxious? You can't make your criticisms in some sort of civilized way. You just have to be rude, obnoxious, heckling asswipe. Ugh. I'm not the only one making concept simulations. Not that a sim is necessary to understand. Well, apparently it is for some. I mean, I didn't think it really would be either, but I sometimes forget that other people just can't do this visualization thing at all. They can't really use their imagination to do any thinking. It's not a thinking space. It's just some place where they put boobs and big fat asses, apparently, because that's very popular now, big fat asses. So they put asses and boobs in there. That's as far as they can go. So if you can't make your analogy out of boobs and asses, they can't understand. So that's a limitation. I mean, I didn't think of myself as having necessarily better skills at these kind of things, but Tesla kind of says, okay, he uses his imagination, and Einstein apparently was big on using his imagination. So maybe that's the difference between us and you. I don't know. It just helps to demonstrate the rules in action. Well, I think it helps somebody who doesn't understand physics, and that was the point of my point. I'm saying a physicist shouldn't need me to draw him pictures, frankly. And drawn pictures should be more than enough. You know, the explanation that the guy jumps in the boat and the other guy jumps out. You should get that the momentum of the guy jumping out would be different than the momentum of the guy who goes in. That changes the momentum of the boat. Yeah, he should be able to figure all that crap out without me helping in any way whatsoever. So that was my point, is that the expert shouldn't need me to draw him a picture. All right. How equilibrium can work and explain all the described forces in terms of two types. Right. Okay. Let's see. Are you the same person? So, you know, it seems like one troll just really overdoing it. Get what you fucking deserve, shithead. So I don't know what this "that" thing means, but isn't that, yes, I get what you deserve. You really think you deserve something other than what you're giving the world, and that if you ever did have a good idea, or even an idea that wasn't just asses and boobs, that somehow you would want people to do this to your idea, right? Yeah, I don't think you would. All right, please continue to pretend his theory fits all of Maxwell's equations. Well, the only equation that doesn't fit is the one they never use, which is the one that there's no monopoles. Of course there are magnetic monopoles. And a lack of drag, and so on. So again, this drag subject, so they keep bringing it up, and the irony is, right, that it took me to discover this for them, right? I mean, apparently Feynman never even thought about it for 10 seconds. Because when he's talking about drag, you know, that, oh, you're hit by more rain in the direction you're, you know, moving. That seems to be exactly what happens to electrons and protons. That's exactly the truth. They are dragged to a halt. And it just seems funny, you know, that a theoretical physicist who worked on the bomb even wouldn't know that. You know, he wouldn't have that stuck in his head already, that, hey, you know, that is a curious thing, that we can't shoot electrons anywhere, you know, that they completely run out of gas, run out of momentum, that we can't trap them in a trap. We can't put them in an accelerator and they shoot out at one end of the accelerator at 100 miles an hour, and then they come into the bottom of the accelerator at 100 miles an hour. No, they come into the bottom going 10. And we have to slowly and slowly and slowly and slowly build up the speed. I mean, I have to point that out to you, that there's no other explanation for why the accelerator has to work so hard and it takes so much energy. Why does it take so much energy? The magnetism shouldn't be hurting the electron any. You know, trapping it in a field shouldn't mean anything to it. A balanced magnetic field shouldn't be wearing it down. So why does it slow down? And why does it slow down in free space? Why can't I shoot a stream of electrons at the moon? So why don't you answer that question if you're so smart? Anyway, the joke is on you ultimately. Feather Kuzman probably understands what I mean here. I'm just saying, what do you mean? You mean to make a counter argument, yet you don't make one. You don't cite any evidence that somehow I have said something that doesn't account for drag, when in fact it's Feynman who said something that doesn't account for the fact that there's already evidence that drag is a real effect. The evidence is already right in front of you. What's your counter argument? Oh, you won't have one, because that's right, you only ask questions, you never answer any questions. And the fact that you make unsubstantiated claims like this is yet another demonstration of how careless a thinker you are, how much disregard for accuracy you have. So the fact that you make unsubstantiated claims like this, and the claim is what, right? I mean, Superior Mind didn't make any claim except, hey, are you the same person? He asked a question. Okay, asking a question is not a claim, especially when it's asked in that manner. He didn't ask it with any obvious, you know, ulterior motive. So again, they can't even do the fundamentals of a rational conversation. And so Superior Mind says insane. Well, it's, you know, it'd be nice if we could just blame insanity, whatever that is, like his brain can't work, you know, But no, it was made not to work because he was raised by obviously a crack whore slut. And his father was obviously a piece of shit with no integrity or decency or not a bit of madness in him. He was a weaseling, draft dodging, like every bad thing you can come up with, piece of skunk weed. Obviously. That's who raised these people. What else? What other rational explanation is there? Where did he learn to be a jackass? All right, you completely don't understand the thing about analog clock. Yes, of course I don't understand. You're telling me there's some meaning in the fact that we've figured out that we can make, the same device do things over and over again by making them circular. Yes. It's an easy way to get the starting line to the finish line is to make a circle. We have like race car tracks and you go around them 200 times. Lots of ways to make it nice and compact. So, yeah, we don't have to carry a 24-hour clock that is, 16 feet long. It just wouldn't be very convenient. But yeah, I don't know what the fuck you're talking about, right? As this has any meaning to anything in physics. Probably on purpose. SMFH. Whatever. What, suck my fucking hat? Okay, I don't think I will. The idea is the two hands align to form a straight line. Now and then they do that. Yes, very fascinating? No, not fascinating at all. I think the configuration of the hands is at exactly 6 o'clock. Yes, very. But, or maybe 2:45, Yeah. How many times a day do the hands do that? I would guess 2. It's a chasing thing, right? I mean, the clock is 2 sides, just like the battery, and just like you could argue about all this kind of magnetism stuff, lots of stuff. It has 2 faces to it. Okay, and maybe it has to do with the 6 faces of dimensionality. The up, down, left, right, forward, back, and that's sort of interesting. That the planes that these things exist in, one dimension is always 2 of the dimensions are on the same plane and one of them's off the plane, which is sort of interesting. But anyway, how many times a day do the hands do that? Form a straight line like Olsen twin figures? I don't need to say. I mean, these people are so, that they're a little bit, perverty too. Just right out here in the like the Olsen twins could be at all interesting. Just somebody who's not 13. Anyway, that was the bloody question. It's a question. I don't understand it. Sorry, I don't understand what it could possibly mean. What is the relevance of it? Not whether clocks could be square, although obviously there are some clocks made in the shape of a square. Well, I wasn't even arguing that would matter. I mean, they still have a center, all right? And the fact that you have a center and then you have action, I'm just saying, why is this interesting? I just don't understand why you think this idea of equal distance from 2 points going in some other dimension would be somehow interesting. Klondike bar. Jesus Christ, every time I think Gary can't get any dumber. And dumber how? Because I can't freaking figure out what the hell you think. Why do you think clocks are this interesting? I get amazed even more. Really, what an illiterate dumb fuck. So you're illiterate if you don't understand this brilliant argument that somehow the universe is, a woo-woo-verse because clocks are round. Yeah, sorry. No, I'm not getting it. Alright, so let's just block this asshole. Jeez. Yes, you're done here. You obviously don't want to make a rational contribution. Alright, dude's not that smart. He drew Floyd's album cover, The Dark Side of the Moon, all wrong. LOL. Oh, God, just shoot these people, please. And people are surprised that I would say if there was a red button, I would hit it without not even a first thought. I would just reflexively fall on it with all my might. I mean, what is there about you people that thinks that it's all worth preserving in some way? I wouldn't even want the record of the human race's existence in this universe to be preserved. There's nothing. I mean, if this is the kind of shit for brains you can produce, what's the point of producing any of it? Wow. I mean, it's just, you know, ha ha ha, yeah, oh yeah, cool. Oh, stupid. Alright, here's how I would phrase it. Alright, so let's see what he does to this now. A force bit is not the smallest, but also the lightest thing possible. It's not only the smallest, but the lightest thing possible, right? Same goes for its rigidity, maxed out. Well, I don't know, who cares? It doesn't interact, frankly, with anything like another force. So you could argue that it doesn't need any of it. And as sort of argued before, if the forces were perfectly kinetic, you know, hitting each other would be the same as missing each other in terms of the universe couldn't change, except for the blue-red thing. And I've already argued that maybe that's just a dimensional thing. Reds are never on the same tracks in the universe that the blue things are, so the two of them never hit each other. Same goes for its rigidity, maxed out. Okay, so I wouldn't bother speculating on that, but if you wish to, go ahead. Just like matter has no... Everything's... Yeah, my battery's gone flat on my solar thingy. Solar thingy. That's a complex term, Gary. Well, it should be off now anyway. I believe so. Can't see the thing. Well, anyway, sorry. Lots of details in my life to take care of. Anyway, just, you know. Right, just as matter has no possibility to accelerate to light speed. So I would say it has the possibility. So you can say it doesn't have the possibility, but yeah, it does. It just won't be matter anymore. It'll be force. But anyway, light force has no chance to decelerate at all. Well, I just don't see any point in trying to make boats into swimmers or rowers. But go ahead, you know. It could be that it's all, you know, the boat's an illusion, and the swimmers just get into a clump that makes them look like they're rowing, but they're really just swimming. Anyway, let's say both these things are tied to their weight. Matter has a wide spectrum of weights and speeds. Well, it really doesn't on the scale of the electron and the proton. The boats really aren't flexible. But really high speeds are blocked off due to structural limits. So again, I don't see any point in saying yes, boats are harder to group in one direction. It's hard to make all your boats go in the same direction. Light bits have a short spectrum of weights they can have, being one. Alright, and that translates to the number of speeds it can inhabit. So I just think this is a apple-orange kind of thing. If the thing with weight is... See, there is no weight. There's just force. So, I mean, people do this with the idea of you know, a thought experiment or a way of visualizing. You know, you take a box, a perfect box, and you put photons in it, and they reflect perfectly in the box. The weight of the box, say if the box doesn't weigh anything, and you're just going to weigh the photons are going to weigh based on how much they hit, right? So, you know, all you're really doing is measuring how much force is in a direction. So if you put the photons going in one direction in the box, then you'll get a different weight than if they're randomly put in the box, because now they can bounce off surfaces all at once. And all of them will say, this is how much we weigh, because all of us hit you at the same time. But they won't, you know, and then the weight will disappear, you know, that kind of thing. So you can have lots of ways of understanding it, but the point is that mass really is, okay, just force in a direction. force makes mass, or makes the realization of the mass. And it just has to do with its direction. So if I change the direction of all the photons, I can make the top of the box weigh a lot. I force them down, I can make the bottom of the box really heavy. But it really just has to do with what direction they're moving, and that'll decide what you weigh. So an electron, when it's moving, weighs more. It's like a bullet. A bullet weighs a tremendous amount. When it hits you, it weighs a lot. Now, you don't say the bullet has a mass of 1 million pounds, right? Even though it's acting as if it has a mass of 1 million pounds, because it's going right through your fucking head. And in the other directions, it doesn't seem to weigh anything. I mean, if I put a scale next to the bullet and I shoot the bullet across the scale this way, it's just not going to weigh anything. All right. So I'm just saying this is a layer deeper than really you need to go in terms of arguing conventional physics. And so that's all I would say, is that, yes, I think they have it all wrong, and they have no concept that what the matter is sort of just arrangement of force. It just has to do with which way the force is going dictates what the matter is doing. All right, anyway. And that translates number of speeds it can inhabit. If the thing with weight is causation or just correlation, doesn't matter, no pun intended. Whatever. I don't think there's a relationship. Since this is where they get something in physics wrong, right? Because they talk about weight gain. So they talk about this thing moving. And the faster I move it, the heavier it gets. It doesn't get heavier. It certainly gets heavier in the direction it's going, right? In the sense that it's gonna hit with a huge amount of weight. And their argument is it's harder to push it. So they're saying it weighs more because it gets harder and harder to push. And as I've pointed out, it could be that it's getting harder and harder to push because there's less of the little bits to make go in the right direction. So as I get them all going in this direction, there's very few of them going the wrong way now. And they're very hard to hit. So I have to send a lot more force in to increase the odds that I'm going to hit those stragglers, the ones that I haven't been hit yet. So in a way it gets lighter, and it gets so light that I can't hit anything that needs changing. And if I can't hit the stuff that needs changing, obviously I can't push it. So in a way it's getting more and more transparent from behind. The faster something's going away from me, the more transparent it's getting. The harder it is to see, the harder it is to push. And it just doesn't have anything to do with it getting heavier. So I'm just saying, these are all decisions that physics could make, 50-50. You pick one or you pick the other explanation. Jamming, wave interference. These are choices. And my argument is they've made they've had the last 100 years, they've done a lot of really bad choosing. Just like Benjamin Franklin chose positive and negative, wrong. And physics is continuing that tradition of bad guessing. And in some cases, insane guessing, where they don't guess heads or tails. They guess some stupid thing, like it's going to land on its edge, and that would be wave-particle duality. Just an insanely stupid guess. All right. Head tails. It's going to come up head tails. I mean, you can't do that. There's nothing being hit by light. That isn't the same size or light particles losing velocity to surrounding stuff. They're just too small, elementary. I don't know what that means. So we can expect to see fancy angles in their collisions since there's nothing capable of spin or squish comprising it. We can't expect to see fancy angles. You can't expect it because the transfer of the momentum is complete and I dare say instantaneous on the nuclear level. Electrons aren't cue balls. They're not made of a whole bunch of stuff that has to be moved in a new direction. The force doesn't have to move through the electron and change everything, in a sense. is the argument. It's just changing one little bit, the momentum. So it doesn't matter what hits the cue ball, the round part of the cue ball. It doesn't matter what it hits, just this little edge over here or just this little thing over. That kind of crap isn't going to matter because there's no dulling of the impact. It either hits it or it doesn't hit it. And the exchange is always complete. That is, the one ball moves the direction the other ball was moving, and this ball moves the direction that one was moving. So it's always a complete transfer. You can't do partials. Until now, I didn't clearly know what I'm even getting at, so here goes. Okay, I guess I'm trying to turn the boats and swimmers movie into something more dumb like a pool table. Yeah, well, my only argument is that whether you use boats or blah, blah, the rules, you got to make the rules and just say you can't split the boats in half and you can't do this and you can't do that, just the way it is. Because this elementary particle is elementary. It doesn't have complex things like wood in it. Nothing's made out of wood. Something that on its face sounds truly Newtonian. Yeah, well, I hate that term. Sorry, yeah, just, because people use this as if Newton said things he didn't say. They keep implying that somehow Newton had an opinion on how fast the force of gravity is transmitted, and he didn't know. So they assume because he didn't put it in his equation, a time factor, that somehow he didn't think there was one. Now, he just didn't know. So he can't put something in. You can't put a placeholder for it and say, well, let's assume there is a time factor, and I'll put it in because there probably is one, but I can't give any value to it, so you'll never be able to solve any of the equations because we can never know what the time value is. You know what I'm saying? You can't put something in the equation that just won't be of any value because nobody knows the variable. It can never solve for it, so what good would it do you? And they make this into some kind of statement that Newtonian physics means everything happens instantaneously. No, that's not what it means. It means that at the time Newton wrote the equation, that's all they knew. I might have stepped into another trap here or there, but I still feel relieved for now. Well, I just, like I said, frankly, pool balls aren't going to get to the idea that the electron has a memory of its previous encounters, essentially. The reason why the boat thing works is because the boat thing creates this idea that you're capturing momentum. You're capturing it. It's changing you. It's physically in you. So the photon hits you, it stays inside of you. Its momentum in this direction is still in there. And until you give that back to the universe, it's inside of you. Okay, and it's doing things while it's stuck there. While it's in the trap, the cul-de-sac, it's still imposing momentum in a direction. That's the catch of it, and that isn't going to be understood by thinking about pool balls. All right, by the way, did you get my mail? Yes, I did. I don't remember what it was, though. But I did get it. I remember getting it. I think it said something about something, but I can't remember exactly what you said. So, sorry. Thanks. I just can't remember. See, the other guy emailed me too. The other guy that was sort of an practice physics or whatever his name was. Anyway, that guy, he also emailed me, and so I'm just going to end up getting everybody confused. All right. Anyway, also, since you're obsessed with right angles, it's like your four corners of the globe. Also, since you're obsessed with right angles, how am I obsessed with right angles? Where's this evidence of that? Sorry. I'm just saying it's a fact of reality, okay, that back to the magnetic field lines, that the force always travels perpendicular to the action. The reaction is, in fact, a perpendicular effect. So I'm just saying it happens in the elemental physics. So you sort of have to account for that. So you sort of have to talk about right angles because it happens in nature. I mean, angle in, angle out is a right angle. If you have any kind of brain, you can figure that out. But anyway, How many times per day do the hands meet at right angles? It's probably the same as the number of times they are a straight line. It's chasing, so there's one chasing and one following. You're chasing going this way, so there's one, and then there's another one when you're, you know, being chased. And what times of day are they? Who cares? So you want me to bother wasting my time on this? You really think there's some meaning to round clock faces? It has some relevance to elemental physics. Don't strain your brain, Gary. That would break my heart. Well, don't strain credulity by thinking that you have to explain why you think this is important. All right. I just figured a physics guru could answer this in his sleep. I'll bet you real money. So if you want to put some real money on the line, like, a few $1,000, I'll bet you real money that you could ask 1,000 physicists and require them to answer fast, and they'd have to think about it. They don't have that answer stuck in their head. Oh, yeah. Straight twice an hour, so that's, whatever, 48 times a day, and, they're exactly perpendicular, twice an hour, so, 48. Whatever. I don't know. I don't think they're going to have it right in their head. With one arm tied behind his back. So I don't think we need to bother, for the sake of the bet, to tie any arms behind their back. But you're saying they could do it even though I just woke them up from a sound sleep, let's say. They could still do it. I don't think so. I don't think half of them would get the right answer in, say, 10 seconds. They get 10 seconds to think about it. I don't think half of them will get the right answer. Maybe I'm not very good at figuring out who the physics gurus are, though. I don't even know why you're looking for a guru. The whole idea is to look for somebody who's making rational, logical arguments, defending a case. So you're really just judging people as lawyers, okay? And so there's obvious things you don't like in a lawyer, right? As a liar, okay, one who sits there and says, "Oh yeah, there's a bunch of evidence over there." I'm not going to detail it though, but you just believe me. There's a bunch of evidence. Yeah, there's a bunch. What kind of lawyer do you want? A shyster? So I'm just saying that's what all you need is the evidence can't speak for itself, because for it to speak for itself, you have to have knowledge of it. Okay, and you're just not going to be able to do that. You're not going to be able to be an expert on the function of the electron microscope and your car and engine and this. You can't know everything. So in some ways you have to rely on these attorneys who show up and tell you what evidence is really important. Oh, we got this gun, and the fingerprint thing. Well, that's good. We got some DNA. We got this kind of evidence, and I can support a theory. And that's what you're supposed to be judging. You're not supposed to be looking for fucking gurus, asshole. You're just supposed to be looking for somebody who's made himself familiar with the evidence and can point out to you that, well, no, that blade of grass from Shea Stadium in 1969, that's not really relevant. Don't worry about that. All this other little crap, and just show you that, well, this is the experiment that matters, right? So physicists tell you the double slit experiment is this fundamental foundational experiment, and they'll tell you that when the detectors are on, this, that, and that, but they'll tell you all kinds of stories about that, and then I'll show up and I'll explain to you, hey, when he told you about this detector shit, none of that ever happened, okay? Those experiments never took place. There was never any result. There was never evidence that, all of a sudden the wave function breaks down and all this kind of crap happened. No, never happened, okay? They just think that's what's going to happen, but they never did the experiment. But you can't do the experiment. It's a silly experiment. And, when these images are being projected over here with the, the multi-slit, I can show you a little star pattern. I can put it right in front of the laser beam, and I'll show you a little star pattern I'll create. And there's little stars in all the locations, because an image is being projected. And then I'll explain to you how there's no theory for wave interference making those images in all those locations, because you can understand that if I had an image of something and then I randomized it, like their mathematics says, it's all random. nothing knows really where it is, these photons. They get randomized when they go into the slit, so it doesn't matter whether one goes close to the edge or goes far from the edge. All the photons randomly decide where they're going to go. So you've taken this image, and now you don't care that, no, it had to go in direct places in the slit. Each little piece of the image had to go to a specific location inside each little slit for there to be a projection in all these locations that's still coherent to this image. You could understand, I could explain to you, right? That there's no wave interference theory that makes that work. That you can't randomize it and then have their destructive photons that get destroyed. That won't work. You can't make an image that way. And then photons that get doubled. You can't, no, it won't work. But whatever. Do what you want to do, fuckhead. Yeah, fuck off. That's what you should do. Just fuck off. Alright. I think I've already blocked them, but I'll just block them some more. Ugh. Assholes. Alright, so I think that's it. Alright, so now just a little bit on... Sorry, I ran out of... Give a damn. The animation. Alright, so the one thing I thought of was, the perpendicular action, and just at least in the... when it comes in sideways to the motion of the electron. Yeah. Or the proton, obviously. The bits. Okay, so the bits moving this way, and say something, the opposite force hits it this way. I would argue that that reaction will be to the force will leave this way. Now, if it's moving this way and the red thing comes in this way, now we're deciding which way, left or right here. I would argue that that would be random. It'd go this way or this way. Now, if there's an angle, then the angle would be the same as this rule. So, if this, get rid of this, and it's going, let's say it's going this way, and the red bit hits this way. So, this angle, as this angle increases, it would increase the likelihood that this bit would leave in the direction opposite this direction, so that would mean perpendicular to this motion, so it would mean this way. So, a little bit complicated, but that would be, I would say, logical rules anyway. Rules that make sense for understanding that it has to be some simple rule. So the simple rule is it comes in sideways, it goes the opposite direction of the motion. Yeah. Okay. Next. So then the thing comes up of about how to make the speed proportional. So this is what I came up with. And I came up with it really fast, which surprised me. I mean, I thought about it for like literally 3 minutes or 2 minutes. And so I'm thinking there's got to be other ways to do it that would be kind of simple. So my idea is that, so you have this idea of the momentum, and you have this idea that what you want to duplicate is an exchange. That is, a guy goes in and a guy comes out. All right, and you want it to be as close to, something this way and something this way leaves. But what you're going to be stuck with is that in some cases, the one that's going the most opposite to this direction would be something that might be going this way. Like everybody's going this way, perfectly straight, and there's one guy a little bit crooked. Well, he would be the guy you would exchange. He's the guy you get rid of and replace it with a straight guy. So that's a hard concept to put into math, is the argument. And it has to do with this whole drag argument. The faster you're going into the force, the more force you're going to hit. You're going the opposite direction you're going. And so there should be a stronger impact in terms of your change on the momentum of the object. So this exchange doesn't mean that you just plussed this, right? You minused this. So you have to account for the fact that it's a double of the force impact on the electron. To the electron, a 2x change took place. I lost something going this way. power, and I gained power going that way. So that's a doubling. You have to add both. You add this vector to this vector, and this is your total increase in momentum. All right. So that's what makes it a little complicated. So the way I thought of doing it would be is you just figure out, the idea of making registers and seats in the boat, literally, is probably too demanding on the computer to account for what was its history, and have 24 locations inside or whatever, and accounting for its all the seats in the boat. And so a way that you might be able to make that without cutting too much of it, the value out of it, was the idea that you're going to add momentum to a system, and the system in any dimension, right, has this way and this way, and the idea is you want to represent cutting that into, say, 25. I'd say for the electron is going to have an odd number and the proton would have the even number, but regardless. So let's just do the proton examples. That would be 12 would be the middle, all right, and you could say this would be 0 and this would be 24, and that would be for something coming this way. Whoops. Exactly wrong again, Gary. All right, so if it was coming this way, the force hits it, and the object is, let's say, if it's moving this way, right, at its maximum speed, then it would be a full 24 quantas of energy. So the impact would create a 24 exchange. That is, this would add 24, a full momentum change, you could argue, or however you want to. I mean, you still have to do the net thing, but I'm just saying, let me just think how to say it the right way. Well, anyway, how much it's going to change this overall system, the amount of change that'll be created, how much impact it'll have on the net, well, you're not even considering a net, you're just saying it has a momentum in a direction, and you're saying how much, so let's just say the net direction is heading, see, to be a full 24, the net direction would have to be the maximum speed, the speed of the force, the speed of light, and so you're hitting the electron when it's moving the speed of light to get the full 24. So obviously that'll never happen. It'll always be some other vector, could be going that way at a 10, right? So it's going this way with 10 momentums. Well, if a 24 hits, I mean a force hits, okay, the idea would be to recognize that whatever this number is in terms of its momentum in this direction. So you have to just do that simple little bit of vector math, right? It has a component this way and a component this way, this way. And you're just saying, well, it's got 7 this way. So it's got a 10 this way has a 7 in this direction, right? So you're at the 7 is what you're going to be going against. So the idea would be, right, so it's moving with a 7 in this direction. It has the opposing to you, the vector that would be opposing you, okay? So that's what we're trying to find, is the vector opposing this, the amount of force it's moving in that direction. So let's say it's going this way. Just now we'll change the illustration. You're going to find the component of the motion in this direction. That's going to be a 7. And the idea would be is that's what you're going to exchange. So you're going to add 7 in the opposite direction. Right? Yeah. Yeah, I'm sorry. Yeah, I'm stuck. That this made sense last night. All of a sudden, I'm having trouble. So it's going to add 7, but you still have to. in the opposite direction, which would mean this would be 0. You're not going to 0 it, so that's still not, I'm doing something wrong. Well, anyway, the idea was is this would have a 7 that should be creating a new net change. And so let's say if it was a 7 in this direction, you'd add 7 to the 7 and get 14, and then divide that by the 4 dimensions. Well, something like that. Yeah, unfortunately, I'm not remembering. Well, anyway, the point would be is if the force comes in the same direction, obviously it would be a 0. So that would be the idea, to understand you're adding no momentum. So if the thing is going this way already at the speed of force, you could understand that this can't possibly have an impact on this, so it would be a 0 encounter. Now, it couldn't happen, obviously, but I'm just saying, so let's just make it, this is going a little less than the speed of the force, so it's going just 1 here. Well, then this would only have a 1 impact in terms of making it go a little bit, it would only add 1 to the net momentum. And then if it was going a little bit slower in this direction, then this number increases, right? So this could be 11, and so you would add 11 because it's going slowly in this direction, so you're adding 11 worth of momentum. Now, it's a lot less than the 24, but it's a lot more than 0. All right. Well, sorry, I sort of made a mess out of this, but you might get the underlying concept. There might be some value in it to somebody somewhere. Yeah, I can't say for sure. Anyway, there's a lot of stuff to have been working on, so it's, my bad for... There's a net momentum that's this defined, and it has a certain weight. So its weight obviously has to be more than 24, because there's 1, 2, 3, 4 dimensions, let's say, or 4 quadrants. So you could argue that it would be out of 100. So the 24 would be out of 100. There'd be 100, and so the 7 would be added as a change of 7 in this direction out of the net 100 that's produced this net direction. So it would be like 1/10 a change in the momentum, something like that. I don't know. There is math for that. I made a mistake somewhere. I just can't fix it on the top of my head. So anyway, I'm tired. Enough. Do better next time. It's always an easy promise to make. So next time I'll give you a whole bunch of information. So the idea is to get these two forces to act, the attractive force to be as strong as the repelling force, and it's finding that balance that's the tricky part. And that's the part that needs to be worked on. What else? Yeah, and obviously the movement has a lot to do. If things move too fast or too slow, that's like temperature or something. It's like if you were to model the temperature on the Earth, right? I mean, there's a number of little subtleties that you'd have to have under perfect control to get it to work like the Earth. To have a North Pole and South Pole frozen, and to get it all right. And so there's a little subtlety to this, and so you just have to have all these little things subtly correct. You got to figure out which things are right, and which things are causing exaggerations or unwanted effects. Well, whatever. Enough. I'm tired. Enough. Save recording. Yes, that's what we'll do. We'll be done. I could, sorry. Wasn't as big as wasn't as anyway, wasn't probably as useful as I intended. But yeah, if somebody has some easy way to mathematically represent an electron holding a history and changing its momentum by this exchange principle, the fact is you're not going to be when something has momentum in a direction, you're not going to have very many things moving exactly the opposite direction, and that means you're not going to have much to hit, and so you can't have as much impact. So when you hit it and it's moving in the direction you hit it, you can't hit it as hard. That's the simple rule. That's the simple effect. When a swimmer jumps in the boat and he replaces somebody that's going almost, the same direction he's going, that can't have the same impact as when he replaces somebody who's going exactly the opposite direction he's going. So it's that idea represented mathematically. Okay, enough. Look at that. I can't even change my mouse. Anyway, till next time. Such.